Hello guys, welcome to this lesson about trigonometric graphs and interpretation of such graphs. Now, what we have here is of course a question with a corresponding diagram or sketch of the graphs, as well as the follow-up questions that go with that. Okay, so the skill that I want to encourage in this lesson, or the approach, is that you read the main question, you extract information from the equations and the main questions and see how they link to the sketch and how you can go from here now to the question. That is building a mental roadmap, or if you like, a mathematical roadmap to the solutions of the questions. All right, so let's go for it. Sketched below are the graphs of f of x equal to cos x plus q and g of x equal to 2 sin bx for x element of negative 60 degrees to 120 degrees. We do confirm that that is the interval for which these graphs are sketched. Okay, we go back to the equations. Let us see what information we can extract. Let's start with f of x. What do we see? F of x is equal to a cos x plus q. The coefficient of the function is 1, so that will always give us the amplitude. And remember, amplitude is always a positive quantity because it refers to length. Okay, so now what else can we pick up? The coefficient of x here is 1, x being your angle, so the period of this function is 360 degrees. Okay, good stuff. Now, what else do we pick up here? We see that we are taking a cos x, we are adding a constant q to it. And this q indicates for us what? A vertical shift. Okay, so you recall that without this constant q, we are talking about our basic, or really our original cos graph, that is an oscillation between -1 and 1. Okay, negative infinity to infinity. So that is the situation there with f. And if we compare now the graph of f to the equation, we can see that there has been a shift, definitely, of the original cos graph, because the original cos graph, its maximum is at 1 and minimum at -1, and is an oscillation between the two. Okay, so in other words, if we, in our minds, superimpose the original graph on this system, we can see that the original graph is shifted down by some units. Okay, and those units we will be determining in a short while. Okay, just want to fix this one. In the question is a q. Right. So this q value, since we have determined that the graph shifted down, we expect that when we calculate the value of q, it will be negative. Okay, good stuff. We come here now. G of x is equal to what? Coefficient of sine is 2, so that gives us our amplitude. The amplitude of this graph is 2, and clearly we can see from the equilibrium position, okay, the maximum is 2 and the minimum is -2. Okay, so that is the amplitude, and we can see that we're dealing with sine. However, something happened there with our angles. There has been a multiplication by some constant b, and this b, we understand that it will affect our period. Just like cos, sine, the original function, its period is 360. However, if you are multiplying it with some constant, then you will be dividing it by that particular constant so that you can get the period, okay, of the new graph. So the original sine graph, we understand, just like cos, its period is 360 degrees, okay? However, if you now check the sketch, the full cycle, okay, of this sine graph in red right here is 120 degrees. Okay, goes to maximum, goes to minimum, comes back to equilibrium. So it is 120 degrees. So from 360 to 120 degrees, what has happened? This original graph from 360 went to 120. So it has undergone what is called a horizontal compression. Okay, by multiplication of a factor b, and that b will be what? Will be 3, because 360 divided by 3 is 120. Okay, so I believe you are with me so far and I'm making sense. All right, so let's start with the first question. However, before we even go to the questions, let us interrogate the sketch, and see, what things mean before we get there. Okay, this one, that is the beginning of our interval. Okay, this point right here is the point of intersection. Okay, so it is also an x-intercept for both graphs. Okay, and that point right there is a minimum. Okay, and this point right here is a what? Y-intercept for G. Okay, and this point right here is a y-intercept for F. However, by symmetry, if you ignore this part for a moment, you can see that that y-intercept is the maximum for F. So this is your maximum as well. Okay, this one is the maximum for G. Okay, what about this? That is a point of intersection, and it is also a what? X-intercept. Okay, what is this? This is a minimum, okay, of G, and what is that? This is a point of intersection. Okay, and we just missed this one. This is also a point of intersection. Okay, so the diagram will always be a skeleton. Okay, using your math knowledge, you want to add information, and that becomes the flesh of the skeleton, and it becomes more sensible and tangible to work with like that, because you would have connected things and put labels, and hopefully correct labels, so that you know what they mean and how to use them in the questions. All right, good stuff. So let's start with our first question. A, determine the values of B and Q. So B is your factor right here. So we have said that it is 3, because 360 divided by 3 gives you 120. That is the full cycle of the new graph after it has undergone that transformation. Okay, so B is equal to 3. It's constant. Okay, and Q, what has happened there is a vertical shift by some units down. Okay, so we need to determine that Q looks like a 0.5 there, that the original graph shifted 0.5 units down. However, we need to confirm it, because looks can be deceiving. We need to be mathematically accurate in our reasoning. So we can choose a point on F, because Q has to do with F. So this point of intersection is, of course, on both graphs, and that one and that one. Here we don't have coordinates, so we can either use that one or that one. Okay, even there we don't have coordinates, so we can use a 60 degrees point of intersection and then work with that. So using this one, 60 degrees and 0. Okay, we substitute in there, we have 0 equal to cos 60 degrees plus Q, and this gives us cos 60. Remember, 60 degrees is one of our special angles, so this is equal to a half, or you can write 0.5. Transposing the half to the left hand side, this gives us a negative half. So Q is negative 0.5, and we did anticipate that sign for Q, showing that the original graph of cos shifted downwards by just half of a unit. Good stuff. B, the follow-up question. Write down the period of G, okay? That is the interval where the full cycle of the graph will be seen, or where the full cycle of the graph will happen, okay, of the function. So how do we see that? G is this graph right here. From the equilibrium goes to the maximum, comes back to the equilibrium, goes to the minimum, and comes back to the equilibrium. So it is a full cycle of G, and the period is indeed 120 degrees. Okay, so C, for which values of x is f strictly increasing? Okay, strictly increasing, we don't want to cover points where it is not increasing, where it is even decreasing. So it must be strictly increasing. So let us evaluate or observe the progression of f from left to right. You can see from negative 60 to 0 it's increasing, and by symmetry we can see that after the maximum, yes, then it starts to decrease and it continues to decrease. So the interval that we're looking for, which is the answer to C, is negative 60 to 0 degrees, and we write it like this: x element of negative 60 degrees to 0 degrees, and negative 60 inclusive, 0 degrees exclusive, because that is the maximum where f is changing its progression from increasing to decreasing. Okay, good stuff. So far, I believe you are still with me and you're enjoying the maths, right? The last question. Write down any x value for which f of x equal to g of x. Well, you just need to pick one and don't make your life difficult. So any x value for which f of x equal to g of x. What is this in simple language? This is just asking you for what? The point of intersection, okay? But we don't want the full point. The question is clear, the x value. So don't worry about the y coordinate, okay? So how many points of intersection have you identified? This one, straightforward, and that one is straightforward. These two are not straightforward. There needs to be some calculations and manipulations that take place. So any x value, we can take a negative 60, x equal to negative 60. There, the graph of f and g have the same x coordinates and they have the same y coordinates because it's a common point, it's a point of intersection. Okay, so in this lesson, focused on amplitude, period, okay, horizontal compression of a graph, as well as vertical shift. Okay, so this is really the basics of this topic, and I believe it was helpful to you, and I am going to leave it here. Thank you very much for tuning in. See you next time. Sharp, sharp.